Today we're going to look at solving polynomial inequalities. First thing we're going to do is we're going to review how to factor and solve polynomial functions using our calculator. So the first thing we're going to do is we're going to click y equals. And we're going to put in this first polynomial function. So x to the third power, we're going to use this caret button. And then we want our cursor to come down, so we're going to arrow over minus 3x squared minus 18x. And now we're going to do second graph to get our table. So we're going to find where all our y values are 0. So we have one at -3 and one at 0. And then we'll keep going. This is just going up. I don't have any more solutions that way. Go this direction, and I have another one at 6. Because this is a cubic function, degree 3, we're going to have 3 solutions. And that's exactly what we have. So these are our solutions. And then if we want to put it in factored form, all we do is we take this number, change the sign, and move it over. So our factored form for this will be x plus 3, x plus or minus 0, it doesn't have a sign. And then this is a positive 6, so it'll become a negative 6. And then x plus or minus 0 is just x. So let's write this out so that it's all on one line. So factored form of this polynomial is x plus 3, and x minus 6. Because then if we were to multiply all of this, we should end up getting this, our original function. Let's do the second one. So we're going to go back to y equals, clear. We're going to do x to the third power minus 3x squared minus x plus 3. Oop, you see what I did? I didn't arrow over, so we're going to go back and clear this. X to the third power, you've got to make sure that you arrow over, minus 3x squared minus x plus 3. Second graph, we now have a solution where x is 3. Keep scrolling. I have one where x is 1. Keep scrolling and have another one where x is -1. So again, I have another cubic, so I'm going to have 3 solutions. To write this in factored form, again, you just change the signs and move them over. So this is x minus 3, x minus 1, x plus 3. And again, when you multiply this out, you should end up with your original function. Let's do one more together, and then you can do it on your own. Right here, it's not equal to 0, so we can move this 15 over. And we get 2x squared minus 7x minus 15 equals 0. And then we're going to put this into our graphing calculator. So y equals, clear, 2x squared minus 7x minus 15, second graph, and I see one solution where x is 5, but I don't see another solution. However, it's going down, goes down, then it comes back up. So you see how it changes in here. I know that there's something going on between this -1 and -2. And because this is a degree of 2, I should have 2 solutions. So if I hit this plus sign, I can put 0.5. I want to find the halves. Hit enter. And when y is 0, I have another solution here at -1.5. So again, if you hit the plus sign, you can find your solutions that are in between your whole numbers. Negative 1.5 is the same thing as negative 3 over 2. So now I can put this in factored form. And I have x minus 5, x, this is a negative 3/2, so I'm going to make it a positive 3/2. And then if you want to get it back to where it's going by whole numbers, hit plus, clear 1, and then it goes back to my whole numbers. So this is how you factor and solve in your graphing calculator. We're going to use this to solve polynomial inequalities. So up here are some steps to go through to help you along. And so we're going to go through this first example. It says place the inequality in standard form. So right now it's less than or equal to negative 12. I need to move this negative 12 over. So to move it over and make it positive. And that's how we get this. So this is the function in standard form. So check, done that. Then it says factor completely and solve. So we get our calculator out again. Y equals x squared plus 7x plus 12, second graph, and I have a solution at negative 3. And then I have another solution at x equals negative 4. To put it in factored form, remember you just move them over. So we factored and solved. Now it says use the zeros of the polynomial and sketch a graph using end behavior. So our zeros for this, I'm going to write out my graph. I'm going to have solutions at negative 3 and negative 4. Because this says equal to, this is less than or equal to, we just found out that these, when our graph is at 0, our x values are, so when the x is negative 3 and x is negative 4, our function's at 0. And because it says equal to, we know that our solutions are at negative 3 and negative 4. And we're going to use closed circles because it says equal to. Then we're going to do a rough sketch based on our end behavior and our degree. So our degree is 2. So this has one turning point. They go in the same direction. And since our leading coefficient is positive, then they both go the same direction. They both go up. So this is going to be a skinny graph, but it's going to look something like this. Now we've got to test points to determine what our solution is. And because this is less than, it's going to be on the bottom of the graph. So our solution is going to be between negative 3 or negative 4 and negative 3. Because if it's greater than, it's above the x-axis, so these are not our things. Because if it's less than, it's below the x-axis. So if I graph it, I can easily see what my solutions are. The other way you can do it is you can sub in values in between negative 3 and negative 4. So less than negative 4, a number in between negative 3 and negative 4, and something greater than negative 3, and it'll also tell you what your solutions are. But if you graph it, you can easily see what your solutions are going to be. Because it's less than or equal to, it's anything below my x-axis. Let's do another example. So for this one, we want it to be in standard form. It already is. Then we're going to factor this out. So y equals x to the third power, scroll over, minus 2x squared minus 3x. And I look and see I have a solution at negative 1, a solution at 0, And then I have another one at 3. So these are my solutions. And so I'm going to do my rough sketch. Because it's equal to, I know I can close my circles at these points. So at 0, -1, and 3. And then I use my in behavior to finish this. So I have 2 terms, odd degree, meaning different ends. And I have a positive leading coefficient, making this mean that it starts going up. So it starts down but goes up. So I'm going to start down, going up. I do 1 turn, I come back down, do another turn, and go up. So here's my rough sketch. This says it is greater than 0. So equal to, I've got my dots closed in, and I want to do everything above my x-axis. So my solutions are from -1 to 0. -1 to 0, we use brackets because I have closed circles. And then from 3 to infinity because it's going up. So that's my solution. This is my final answer. Let's do one more. Okay, it's in standard form. Y equals x cubed plus 2x squared minus 9x minus 18. I have a solution at x equals -2. I have another solution at x equals 3. And then I have another one at x equals -3. So these are my solutions. I'm going to graph this out. And you can also see that your y-intercept is at -18. We're not going to graph that because it's too far down. Because this does not have an equal to sign, I'm going to do an open circle. So I'm going to do an open circle at -2, open circle at +3, and an open circle at -3. So my final solution is going to use parentheses because this statement right here, this inequality, is not true at -2, -3, and 3. Then I do my rough sketch. Same thing. It's going to look very similar to the one above. So it starts down, turns here, and it goes all the way down here, and goes up. Since this is greater than 0, we are going to graph above the x-axis. So my solutions are true between -3 and -2. This is not true, so then it's again true at 3 to +infinity. So just to review, it's greater than, so you're going to go when it's not going to be equal to, so you're going to use your parentheses. Here we have equal to, so you're going to use your brackets. However, if it goes to infinity, you never reach that, so that's in parentheses. So this is how you graph inequalities.